This is a particle podcast. WA Science told different. Powered by Scitech.
Please Look Up is recorded at Scitech on Whadjuk Noongar land. Good evening, everybody. My name is Leon.
And I'm Beth.
And welcome to Please Look Up, your monthly deep dive into space news.
And commentary.
Recorded at Scitech on Whadjuk Noongar land. This month we're discussing the exciting space news of June.
Yes, June already.
It came around too fast.
Really, really quickly. So, Leon, what's up tonight?
Good question, Beth. Well, do you remember last month where I said there were no planets to look at in the evening sky?
Yes, I do.
I've got some exciting news this month. If you wait for the last month of June...
The last week of June?
Sorry, the last week of June, my mistake.
That's all right.
For about half an hour after sunset, you'll get a really lousy view of Mercury.
Yay!
Yes, that's the big planet development this month.
And that's it?
For evening sky planets,
okay.
Yes. Yes, evening sky planet is is not very good. There's the evening sky, but yes, in the last week of the month you will get a very, very quick look at Mercury. But it's always hard to see Mercury anyway. It will get a little bit better in July, and but that's for next month. But for the other planets, just like it was in May, in the morning sky you can see Saturn and Mars there doing their usual. They're not particularly bright at the moment, but they are there before sunrise. And this month in June, they are also joined by Jupiter from about 6:30 onwards, again in the morning sky.
So whereabouts in the sky am I looking for these? Because if I want to catch Mercury and I've got half an hour, am I looking...
Oh, yes. You're looking to the west. So It's chasing the sun over the horizon, which is why it's actually quite difficult to see, because Mercury is so close to the sun in real life that if you're looking in the direction of Mercury, you're looking in the direction of the sun. So
which is dangerous.
That's right, which is why you need to wait for that special moment after the sun has set, but that little window before Mercury also sets as well. It's just kind of there in the twilight for half an hour to an hour after sunset.
Okay, so if you're watching the sunset, looking at the horizon, and then you just see a little bright light, probably Mercury?
More or less. Again, you might want to use our favourite app, Stellarium, to help you.
Still not sponsored.
Yes. Or what you could do is look at what you think might be the Mercury over a couple of nights, because being a planet, it will move, and Mercury moves very fast. In fact, you can tell me, where does the name of Mercury come from?
Mercury is the messenger god.
Yes, and the messenger, because messengers were runners. They would deliver messengers, and Mercury was very fast.
The winged sandal of athlete's foot.
Yes, there you go. Oh, it is too, isn't it?
Yeah, that winged shoe. Mercury.
Mercury in the western sky this month.
So the other planets, it's the morning now. I've woken up.
Yes, Mercury, Mars, and Saturn, Mars, and Jupiter. Interestingly, a good day to go out and look at these would be the 3rd of June, because the moon is actually going to be right next to Mars on the 3rd of June on that morning. So it's going to be within like a finger width of Mars.
Okay, so I can find the moon, and then Mars is going to be nearby.
Yep.
Looking a little bit red.
That's right. And then Saturn will be a little bit higher, and Jupiter will be the bright one on the horizon. Jupiter, out of all of them, will be the brightest.
Amazing. So one of the things that I think that you can see in the night sky at the moment is also connected to Mars, except you'll be able to see this in the evening sky, which is the rival to Mars.
The rival to Mars, that's right. Yes, so we briefly mentioned it last month, but yes, the constellation of Scorpius has very much established itself in the eastern sky at nighttime after sunset, and it's that hook-shaped pattern of stars. And yes, you're specifically referring to one of the stars inside the constellation of Scorpius.
Yeah, Antares.
Antares. Would you like to tell us about Antares?
Yeah, so it's called Antares, or rival to Aries. It looks red in the night sky, just like the planet Mars looks red, which is why it's Mars' rival. But it's red because it's a red supergiant star.
Yes, it is. I believe, if I remember correctly, if you replaced the Sun with Antares, its orbit would extend out to like Jupiter or something like that.
So its surface would reach somewhere between Mars and Jupiter. Yeah, it's a big star.
Yeah,
really
that's amazing.
I think it's one of the biggest that you can actually see from Earth with the naked eye.
Oh, there you go.
Yeah.
How does it compare to Betelgeuse?
I have no idea.
Yeah,
I think they're fairly similarly sized. I think Antares might be a bit bigger, but Betelgeuse in Orion's right shoulder also looks very red, and it's kind of rare that you see both of them in the night sky at the same time, actually.
Yes, that's right. As one rises, the other one sets.
Yeah, but I think just after sunset, in June, you might be able to spot both of them.
Yes, or yeah, if you're lucky.
Yeah, only just.
Only just. It is interesting because Scorpius being one of these so-called zodiacal constellations, what that really means is the orbits of the planets as they move around the sun pass through only certain parts of the sky, and that is called the zodiac. And what that means is, as a matter of fact, Mars, occasionally on its orbit around the sun, will move through the constellation of Scorpius. And so you can see the wisdom in the name of Antares, because you can imagine a few thousand years ago, in the days of ye old, when people are sitting out there going, see that red dot over there? That's Mars. See that other red dot over there? That's not Mars. No. And, just by the development of language, the name of not Mars, or the rival to Mars, just gets handed down to what we now call Antares, which in English doesn't really mean anything, but in the ancient Greek meant the rival to Mars.
Yeah, absolutely. I find that there's names like that which sound like, of course Antares is the name of a star. Like, that sounds like the name of a star.
Yeah.
It's Antares. Like, it sounds sort of, mysterious and not like anything for us in English, because it's not, it's Greek.
Yes, that's right.
Yeah, in Greek it's just not Mars.
Now, speaking of interesting star names, I believe we were chatting about this earlier, the stars within the pincers of Scorpius.
Yes, so this is one of those amazing things that I absolutely love about the night sky, and the way that how we look at it has developed over thousands of years. So Scorpius at the moment, it looks like you've got the hook, the sort of very iconic, very obvious hook, which again is shared across like so many different cultures. Like Polynesian culture recognises it, as well as like a separate constellation is like the Hook of Maui.
Yes.
But so you've got this hook at the end, and it comes up into the body where you find Antares, and then it's sort of got like a line across the top. I think it's like, it looks like a hammerhead shark's head.
It does, yeah.
So it's a bit weird that this scorpion, it's only got very little claws. They just stick out a tiny little bit. But that's because it used to have two really long claws. And there are actually two stars, which in Arabic translates to the left and right claw. Those two stars are in the constellation of Libra.
Of Libra, yes, they've been assimilated in. But yes, I remember, and I believe, I can't remember the other one, but one of them is called Zubin el-Ganubi. Yeah. And I think that's left claw or something like that.
Yeah, and the other one is
Zubin Eshanali or something like Zubin something. And you're right. But in the modern classification, they've been ported over to Libra.
Yeah, and I'm pretty sure it was one of the Caesars. The Caesars did a lot of messing around with months. That's who we've got to thank for October not being the 8th month. Thank you, Caesar.
Yeah, I never thought of that.
Yeah, it's very frustrating, and November should be the 9th month, and December should be the 10th, but no, Julius was like, I want my own month, July.
Yes,
and then
did.
Augustus was like, no, I want one as well.
Month.
So we've got July and August messing up the calendar, and then we've also got Libra messing up Scorpius's excellent Arabic clause. Is Scorpius actually our constellation of the month as well?
Scorpius is not the constellation of the month. The constellation of the month, I think it's time for the constellation of the month.
Oh, it's such a smooth lead-in. Yay!
No, the constellation of the month is one we very briefly mentioned last month, but I want to make it centre stage, is Hydra.
Hydra.
The snake. So Hydra is, as a matter of fact, it is the largest constellation in all the night sky. It covers a whopping 3.16% of the sky, which doesn't sound like much.
But if you think that there's meant to be 88 constellations, 3% is more than its fair share.
That's right. The average would be about 1.2. So yeah, it's about 3 times larger than the average constellation, whatever that means.
It's very long and thin though, isn't it?
It is. It's very long. It covers about 110 degrees of the sky, which is, you only see 180 degrees of the sky at any one time. So it covers more than half of your viewpoint of the sky when the whole constellation is above the horizon.
Yeah.
And this month, Hydra is basically, it's a snake, and so I want you to imagine a snake, and its kind of nose is sniffing the western horizon, and then it's stretching all the way up to pretty much above overhead. Okay. So if you're facing south, looking at the Southern Cross, the head of the snake is off to your right, to the west, sniffing the horizon, and then it's kind of stretching all the way up to directly above your head.
Oh, wow. So Hydra stretching sort of out across the sky. Is there anything in particular I should be looking out for? Like, Antares, a big red star in the middle, or anything like that?
Interestingly, it's actually quite a faint constellation. The brightest star is what astronomers call magnitude 2, which is, it's sort of bright, but it's not even as bright as Mars or Saturn will be which I just earlier said were not going to be that bright anyway.
Yeah. Okay. So
it's not the
pretty
brightest.
difficult to spot.
Yeah, but it's interesting though. The brightest star is called Alphard, which sounds like.
You know how we were saying Antares is a star name?
Yes.
Alphard is not.
Yeah. It sounds like we might have to make that a segment. Star name or not? It's Alphard sounds like.
Alphard's just a dude.
Yeah, someone spelt their name wrong in their birth certificate or something.
He's just an old dude. It's a librarian. I feel like Alphard is a librarian, not a star.
It translates from Arabic as sort of by themselves. So it is interesting because it's a brightish star with no other nearby hugely bright stars.
Okay.
So it is actually kind of plausible that you might go out and spot it without needing a map or anything like that. It's sort of a handspan above the western horizon, and there's no hugely bright stars nearby. The other thing to be aware of though is that it doesn't lie across the central band of the Milky Way galaxy. It's very offset.
Mm-hmm.
So you imagine the Milky Way stretches across the sky where there's millions and millions of stars all lined up, whereas Hydra is kind of off to the side. So there's less stars just in that direction.
Right.
And so as a result, there's less chance of seeing a star, let alone even a bright one.
Right.
So it still just stands out. And the nearest nearby bright stars are actually like Sirius and Canopus. So they're extremely bright.
Yep.
So by comparison, even a somewhat medium brightness star nearby would just be like, we'll just ignore that and we'll call this one the lone bright star.
Yeah, fair enough.
So yeah, if you want to go out and look at Hydra, look for Alphard and and Scorpius. Look for Alphard and then use your favourite app to help you find the rest.
Our favourite is still Stellarium.
Absolutely. Interestingly, if you do have a small telescope, you can point it into the constellation of Hydra. There's two somewhat interesting things I think you should look at. There's a globular cluster called Messier 68. So globular clusters are clusters of like really densely packed stars, like anywhere from a few tens of thousands up to 500,000.
Cool.
Like really densely packed together, and they orbit the Milky Way. So they're not satellite galaxies like the Magellanic Clouds, but they are just these weird clusters of stars. We're not 100% sure where they come from still. It's thought that they are the remainders of what were once satellite galaxies that the Milky Way is kind of stripped away and eaten, and that this little core of stars just remains. And you can see one of them inside Hydra. You do need a telescope to see it.
So, like you said, Hydra is very big. So
yes.
Where in Hydra am I even pointing my telescope? Towards the head end? Towards the tail end?
Towards the belly.
Okay, so sort of right in the middle of Hydra. If you have a look around, you might be able to see this globular cluster.
Thereabouts, yeah. And then the other thing which was really quite interesting is something called the Southern Pinwheel Galaxy, which is another Messier number.
Okay.
This one is M83.
Oh,
and
there's a band called M83.
There's a band called M83, and they named themselves after this galaxy, which is very cool. And it's basically a smaller, neater version of the Milky Way.
Okay.
So the Milky Way is a spiral galaxy. In other words, from the outside, it looks like a disk, and then it's got spiral arms where the star formation makes these spiral arms to kind of stand out. But the Milky Way is kind of loosely wrapped, so to speak. Picture like the fork in the spaghetti, and it's kind of twirled a little bit, but it's a little bit loose. Whereas the M83, the Pinwheel Galaxy, the Southern Pinwheel, is much more tightly wound.
So okay, hear me out. So if you get a mop and you spin it really quickly, the arms go way out. But if you're spinning the mop quite slowly, the arms are tighter in.
Nice and coiled up. Yeah, and that's basically what this Southern Pinwheel Galaxy looks like. Again, you will need a telescope to see it. That's kind of closer towards the head, I believe. Mm-hmm. But use an app.
Yeah. Always use an app.
Always use an app.
It just helps. Why make your life more difficult for yourself?
Exactly. So, Beth, as our sort of resident expert on Greek mythology, I was hoping you could tell me a bit about the story of Hydra. I'm more familiar with Hercules fighting the many-headed beast, and every time he chops off a head, two more grow, and he eventually, I think, defeated it by every time he cut off a head, someone came in and cauterized the...
Yes, yeah, there's some famous images of Hercules, sword in one hand, torch in the other, as he's cauterizing the heads of this beast, which is often depicted with four little legs. So it's a little bit weird when you look at the depictions of Hydra as just a snake.
As a snake, yeah.
So this leads us into a new segment. This new segment is Star Stories.
Star Stories.
So like we alluded to earlier with Scorpius, there are lots of different ways that people have perceived the stars throughout time. And sometimes the stars are just used like a picture book, and people will just see the picture and they'll make up something, and it might not necessarily be related to the other things that that picture is used for. So yeah, Hydra, it's called Hydra after the many-headed Hydra, but the Hydra that you see in the night sky only has one head and it's not got any legs, it's just a snake.
It's just a snake.
And there's another story that goes along with the constellation of Hydra. And so this little star story actually involves 3 different constellations, all of which are together in the night sky. So it starts off with the constellation of Corvus, the crow. So Corvus is sort of at the tail end of Hydra. And the god Apollo sent Corvus to fill up a cup crater. Why?
Which is a constellation.
Yes, crater the constellation. It's called crater, it's a cup, which is why we call craters craters. They're both from Greek.
Oh, there you go.
Yeah.
Gotcha.
Yeah. It's all Greek.
it's
all Greek or Latin.
Right, gotcha. Okay, so
or Arabic.
Corvus the crow, Crater the cup, and Hydra the snake. How are they related?
So, Apollo sent Corvus, the crow, to go and fill up Crater the cup. Corvus got distracted by some fruit on his way. I don't know why he didn't just think to fill up the cup in the meantime of flying home, but no, instead he decided to catch a snake and bring that snake to Apollo and blame the snake for him not being able to fill up the cup. It's like, the snake was in the way, and seeing as I clearly could pick it up and bring it to you, it was stopping. We're not debating the logic of crows. I think in real life they are far more intelligent than the crow from this story. But maybe that's a little bit of a lesson. So a lot of these ancient Greek stories do have some sort of lesson or explanation of why the world is the way it is built into them. And this story says that Apollo was furious that his cup had not been filled by the crow and punished them all by throwing them up into the sky.
Right.
Poor Hydra,
Yeah,
attacked
the
by a
snake had
crow,
nothing to do with it.
stolen from his home, and then chucked in the sky by an angry god. But
That's it.
that's it.
Okay.
But this story's sort of motto is the explanation for why crows sound the way they do.
Oh.
Because the crow had, failed in getting him a drink of water, he cursed them to be thirsty forever, which is why they sound like they're always thirsty, that croaky cawing noise. So that was the Greek explanation for why crows sound the way they do.
There you go. Wow. I thought the motto of the story, the moral of the story was like, don't tell a lie if you're a crow.
I feel like the motto of a lot of the stories is, if a god tells you to do something, just do it.
Questionable.
Don't mess with them. They're angry. They'll probably throw you in the sky if you do something wrong.
There we go. So, yes, and you said, the Corvus and Crater and Hydra are all kind of next to each other in the sky.
Yeah. So all three of them right next to each other in the night sky. I can just picture, someone sitting on a blanket on a hill, pointing out the crow and then telling them about how the cup, which is right next to it, and they were sent to fill it up from, and then also because the Milky Way is relatively near them in that part of the sky as well. Maybe the Milky Way is the lake that they were sent to, and I don't know. I just get very, I love looking at the sky and telling stories.
Mm-hmm. So it's something humans have been doing for as long as we have existed.
Absolutely. So yeah, that's our star stories. Is there anything else that we're looking at in the night sky in June, Leon?
Well, more of the daytime sky, actually. It is worth mentioning that we're approaching the solstice on the 21st of June. And so it's
the longest day.
Well, the shortest day.
Oh, I've moved hemispheres.
You're in the wrong hemisphere.
Day.
Yes, but no, yeah. The solstice is something that happens everywhere on Earth at the same time. It's actually a point in the Earth's orbit. And on this day, on the 21st of June, in Australian time, it might, depending on where you live, it might be in a different time zone. But yeah, it marks the point where the sun is at its furthest point north or south in the sky. Mm-hmm. In this case, it's the furthest point north. So it's winter in Australia in June onwards, and summer in the northern hemisphere. And those are caused by as the Earth moves around the sun, because of the Earth's tilt, the height of the sun above the horizon appears to change. And so in summer, the sun's really high in the sky, and in winter, the sun's really low in the sky. And on the 21st of June, from Australia, the sun will be at its lowest point in the sky, and that's what we call the solstice.
Right.
So in other words, if you go out and look at where the sun is every day at midday,
Yes.
from the 21st of June onwards, you'll see it appearing higher and higher and higher in the sky.
Oh.
It actually works quite well if you've got a yard with a tall tree or something, just to give you a reference point.
Yeah.
If you just go out and look, you can't really tell. But, if the sun is, handspan above the top of the tree this week, and then 2 weeks from now it's 2.5 handspans or something like that, it's getting higher and higher up in the sky.
Oh, wow.
And so, and that's where the word solstice comes from. Sol for sun, and stis, I guess, means stand still. So the sun, it stands still and then it starts going back up again.
Okay. So this, I guess, as well, is the middle of the permanite in Antarctica, or is it?
Yes.
Maybe not the middle, but it's definitely, that is a day where they will not see the sun at all.
No, that's right. Yeah, from here on out, the days will start getting longer.
Yeah.
In the southern hemisphere, it's the shortest amount of daylight for the year. In the northern hemisphere, it's the longest. I don't like the phrase longest day because all days are 24 hours long, but it's the one with the longest daylight in the northern hemisphere and the least daylight in the southern hemisphere. And after that, the days will get longer, which is a bit sad because we've had 23 millimetres of rain since October last year.
Oh, that's not enough millimetres.
and we're already approaching the solstice. However, because of the way seasons work, it actually, there's a reason why we call winter June, July, August, because of the inertia of the climate system. So it's not all bad news, but it's been a pretty miserable.
Fingers crossed, hopefully got rain to come.
Hopefully.
Yep.
All right, and it's now back to our monthly section, my personal favourite, called Spaceflight Focus. I believe, Beth, you've brought something interesting to talk about.
I have. So, for the first time in 2 years, Blue Origin launched a crewed mission.
Blue Origin. They launched the Willy rocket.
They did. It is very phallic. Most rocket ships are, but this one is particularly. So yes, this is Jeff Bezos's space baby.
Yes, it is.
I'm going to talk about the cool stuff about this mission first before I get grumpy about this mission. Sure.
So, for people who don't know anything about the New Shepard, the Jeff Bezos rocket, tell us all about it.
Okay, so Blue Origin are the company. And they launched their New Shepard rocket with a crewed capsule. So they had 6 people on it. It's a suborbital flight, which means that it doesn't go up into orbit. And then I looked into actually how high up it went. It went 106 kilometres up.
106 kilometres.
So it really only just went into space.
Yes.
Space begins at about 100 kilometres.
Yeah,
so they just dipped a toe into space.
They dip a toe there, yes. Yeah, most international organisations agree that 100 kilometres, the so-called Kármán line, is where space begins. And there's no hard boundary. The atmosphere just kind of fades away. Yeah. But 100 Ks is a good thing. So, it really does just poke its toe in there.
Yeah, exactly. And the flight was about 10 minutes long.
Yep.
Something that I think was also pretty cool, pretty scary, but pretty cool as well, is when they began their descent, this crewed capsule, it had 3 parachutes to help slow it down. One of them failed. It didn't deploy properly.
Oh, no.
But the capsule was designed to land with just 2.
Redundancy.
Yep, absolutely. We built in a failsafe, which is very good. So some of the cool stuff about New Shepard, it's a reusable launch vehicle. But this is where I did some digging, and then I got a bit mad. Because Blue Origin, the company, so this is Jeff Bezos' space company, they say they are for the benefit of Earth. That is their tagline. And then literally 2 scrolls down on their website, it says, Blue Origin, this is a direct quote, Blue Origin envisions a time when people can tap into the limitless resources of space and enable the movement of damaging industries into space to preserve Earth. Humanity's Blue Origin.
Wow, that's quite a sentence, isn't it?
Yeah, it's just it's for the benefit of Earth. Instead of trying to stop our damaging industries or make them less damaging, they're just what we'll destroy instead? Everywhere else.
we'll put it all somewhere else.
They talk about this reusable rocket because they want it to be reusable to reduce the impact on planet Earth. They say that they want this reusable rocket so that it's more sustainable. But it's a tourism rocket. It's not. So this is one of the big arguments around space exploration in general, is that launching a rocket ship is horrific for the environment. Like, it is just bad for the environment. You are burning so much fuel, and it's just like there's so much money, so much resources that go into it. Why are we spending this money on getting off our planet when, you know, we're destroying the planet that we've got? Like, can we even be trusted to go into space? These are all ethical arguments that happen around space exploration now. The pushback from the scientific industry is that this is all of the good that space exploration does us, all of the good that it does to do with satellite imaging. It means that we can actually track the changes that we're making to the environment, and we can work to prevent those changes in the future. Like, there's a very careful balance in space exploration. And I think that a lot of the NASA missions and all of that, at least they're justified through scientific research. This is not. This is just a bunch of rich guys going to space.
Yeah, I see what you mean. I'm going to play devil's advocate.
Please do.
This is going to be fun. One of the interesting things about the Blue Origin New Shepard is it burns hydrogen as a fuel.
Yes.
So when you take hydrogen and add oxygen, your exhaust is water.
Yes.
So as a matter of fact, the actual pollution from this particular rocket is actually... it's water. There's no actual other pollution.
Yeah.
So now, whether that justifies the rocket and locking the space tourism market only for the very rich people, that's a different story.
Yeah. So this is. I had a look. I looked into the people going up, and yeah, I do agree with you that that's where this ethical line gets really interesting, because if a privately funded company can develop economically feasible hydrogen fuel rockets that we can then use for something that I think is actually useful.
For the betterment of humanity.
Yeah, for the betterment of humanity, then that's great. Like, if they've got the funding to do it where publicly funded space industries don't, that's amazing. And if we're using tourism to fund that, then yeah, I see that ethical counterpoint. But also the people going on this mission, it's really interesting seeing the different ways the people are described. Blue Origin describes them as astronauts.
Yes.
No one else does.
No one else does. No, because these are US launches, the Federal Aviation Authority over there has jurisdiction over that, and they, I believe last year or the year before, changed the definition of an astronaut specifically to exclude customers on Blue Origin flights.
Yes.
They put in a little caveat that you must do research that demonstrates benefits to the health of humans.
I think, or you
like
have to be performing a task that ensures the success of the crew or mission.
Yes, that's right. So if you're spinning around and making TikToks for the 7-minute flight, then they don't award you the astronaut wings.
Yeah,
but yeah, it's Blue Origin marketing versus federal government definitions.
Yeah, exactly. Yeah, I guess the whole situation just frustrates me, where we've got these 3 billionaires who are just in charge of space at the moment already.
Yeah, it's interesting.
It's like, because you've got Elon Musk for SpaceX, you've got Richard Branson for Virgin Galactic, and then you've got Jeff Bezos for Blue Origin.
Blue Origin. What do you say to... So, New Shepard, by the way, is named after Alan Shepard, who was America's first person into space, and the name's quite appropriate because on Alan Shepard's flight, he went straight up and straight down, just like the New Shepard does. And Blue Origin are using money from this space tourism to pay for the development of their next rocket called the New Glenn, named after John Glenn, who was the first American to orbit the Earth.
Right.
And the New Glenn rocket is designed to orbit the Earth, and it's designed to be a very, very powerful, very heavy lift rocket, very competitive against SpaceX as well, and largely reusable. And as a matter of fact, we've spoken in the past about how SpaceX rockets, they go up and then they land on a barge in the middle of the ocean and they reuse the rocket.
Yeah.
The first patent for a design to do that was from Blue Origin.
Yeah.
So for their New Glenn rocket, the problem is SpaceX got there faster and now kind of get all the glory, and now New Glenn is playing catch up. The problem is Blue Origin are very secretive about their company. SpaceX are a lot more open, so we're not really sure where the New Glenn's up to. It's going to launch in the next year or two on its first test flight. But what are your thoughts about that?
See, yeah, like I said, this is where I'm really torn because
Yeah.
because
I sound like I'm really in favour of it. I'm just
No,
playing
no.
devil's advocate.
Leon just knows that I get very, very passionate about these things and is helping create excellent content while I just sit here and
Well, you
rant
get mad.
about how unfair space tourism is.
You and I aren't going to be able to afford to go to space anytime soon.
No. Okay, so now for a, well, hopefully fan favourite, a Leon and Beth favourite, Space Picture of the Month.
Space picture of the month, yes. So Beth, do you want to go first? Do you want to send me your picture?
Oh, okay, I can send you mine.
It's loading. It's very blurry. It's probably the the internet.
No, it's not.
Oh,
It is this blurry.
it is this blurry. Well, okay, what I can see is a mostly black picture, and it's clearly taken from space, and there are two half lit, so two half discs, one large one sort of to the lower left and one small one to the lower right, and I'm going to guess quite confidently that this is the Earth and the Moon as photographed from a distant spacecraft, and the half disc is because the sun is off, it's off camera, it's off to the side, and we're seeing the day side of the Earth and the day side of the Moon from side on, and then the missing, this dark half is the night side.
You are correct, except that this image was not taken from space, per se. It was taken from Mars.
No.
Yes, so this is the first image of planet Earth that was ever taken from another planet,
Wow. Okay.
which is pretty cool.
I'm very curious now, because what spacecraft did this? Was this something from like the 70s, or is this something more recent?
So this was MGS on the 8th of May 2003.
Okay. What's MGS stand for?
I don't know.
Oh, that Mars Global Surveyor.
Oh,
That's what that would be.
that would make sense, yes. So yes, this is from the Mars Global Surveyor. So I don't, as you may have gathered from these podcasts, my area of expertise in space is mostly just looking at stars and telling stories about them. So I'm not super good at rovers and missions and the like, but I saw this picture and I just thought it was incredible. Like this, I love how recent it is as well. I love that it's from 2003 and that it's blurry and low res. Also, it's actually, the picture is in colour.
Yes.
But it was actually originally taken in grayscale. So this is also from the high resolution camera on MGS.
Yeah.
So the high resolution camera only takes grayscale images. So to colorize the image, there were some Earth and Moon images taken in the 70s from space that they then used to colorize it.
Gotcha. Now, it's worth pointing out, while the picture is blurry, this high-resolution camera is designed to take photos of the surface of Mars, not pictures of Earth from 100 million kilometres away.
No, but I love the blurriness because of how recent it is and just showing that, we never intended to use that camera to take a picture of Earth and the Moon, so that's not what it was designed for. But we did it anyway.
We did it anyway. I'm getting flashbacks to your picture from a couple of months ago with Saturn taken by Cassini, and Earth is in the background.
Yeah. I just like pictures of Earth from space.
Yeah, no, it's it never gets old. Yes, now, if I remember correctly, the Mars Global Surveyor was a NASA mission, and I think it was, from like the late 90s to the mid 2000s is when it was orbiting Mars, and then it just kind of stopped talking to Earth in the mid 2000s.
Yeah, so it's not the surface of Mars.
No, so an orbiter. So, it doesn't land on Mars.
Yeah.
Right, gotcha.
But still, it's from another planet.
From another planet.
It's from Mars.
Yeah, exactly that.
This image is from Mars.
That's very cool.
But
and that's right. There's a growing number of like photos of Earth from space, from like these far off spacecraft, like the Voyager ones that took the pale blue dot and things like that.
There's lots of, and obviously now as well, there's lots of really high res images of Earth, and we're kind of used to seeing Earth from space now. Like, we've got Google Maps and stuff, which you just Google Earth, even you zoom out far enough, you can see
Google
the Earth
Mars.
from space. Yeah, exactly. But this just being this little blurry blue disc, like this. It's an arc as well. I love that you can't see the whole circle.
No, that's right.
Of Earth.
And now looking closer, I can actually, now that I know it's Earth and the day side, I can make out what I think is South America. in the illuminated part of the Earth there?
Oh, yeah, it could be South America. It might be. Yeah, it is. It is. I've confirmed in the context that I have for this photo. So yeah, there's a bright area at the top, which is actually clouds over North and Central America. But on the moon as well, you can see there's a slightly lighter portion at the very bottom.
Yep.
So it's sort of darker at the top and lighter at the bottom. And that's because of the crater Tycho.
Ah, yes.
Yeah, so there's like the way that the sun's rays bounce around this crater
Makes it stand out. Even from Mars.
Yeah.
Wow, now that's cool.
It's pretty cool.
It's very cool.
So this image is from NASA, and it will be up on our Instagram after the show goes out.
Excellent.
Yeah.
Our Instagram is @ParticleWA.
@ParticleWA. So Leon, what have you got for me?
All right, I'll send you my picture now. And I'm going to preface this by saying this is an image from a website called timeanddate.com.
Good old timeanddate.com. You've sent me a graph, Leon.
I have.
Percentage of world population in daylight or twilight. So, this relates to what we were doing earlier. So what we've got here is a y-axis from 76 to 100. And then the x-axis is divided up into columns going across from January through to December. So this is from 11 o'clock UTC. Now, the line on this graph looks a bit like an elephant.
Yeah, it does.
Yeah, so it looks like the back of an elephant. So you're starting in January with the tail, and then it goes up and over, and then way down into November, and then up a little bit again in December. So this, I assume, is relating to our conversation earlier about solstices, solstice? Solstice?
Yeah, solstices, I think.
So in June, there's a peak. 99% of the world's population are in daylight at 11 o'clock in June.
Yes.
And then at the end of November, 77, nearly 78% of people are in daylight.
Yes.
So this is really telling about population distribution on
where
planet
people
Earth.
live, yes. So this I was reading about on the Time and Date website, where it started as an internet meme that on this day, at this time, 99% of the world's population will be in daytime. And it's one of those things that you read and go, nah. And then about a few minutes later you go, but really? And then someone at Time and Date has done the maths, and they've produced this graph that, over the course of the year shows you the percentage of the world's population who are in daylight at that time. And yes, as we approach June, the middle of the year, which is the height of the summer in the Northern Hemisphere, where the majority of people in the world live, this line gets very, very close to 100%. There's a few caveats and a few things to think about. Firstly, it's at 11 o'clock Universal Coordinate Time, which is Greenwich time, basically.
Right.
In other words, it's at 9 p.m. Perth time. So this graph,
Okay.
we're in the 1%.
Right. Yeah.
We are not included in this. And there's a few other caveats where it's technically other parts, like right on the edge of this sort of daylight, are in twilight. So the sun has technically already set on certain parts of the world, but they're still being included as in this daylight area because of the sunlight that spills over the horizon. You know how the sun sets, but you can still kind of see your way around.
I guess they're sort of just saying the percentage of the world not in total darkness.
Yes, that's right. And it's something like there's only about 70 odd million people who are in complete darkness at that time, including all of Australia and New Zealand and sort of the Pacific and the Polynesian Islands, where there's not many people who live. But I'm just amazed at how large that number is. That it's like 99%. And even when you account for all those caveats, it's in the mid-90s.
Yeah.
That, at 11 o'clock on, for pretty much all of June, at 11 o'clock Universal Coordinate Time, or 9 p.m. Perth time, most of the world is in daylight, and we're one of the 1% of the world that is in nighttime.
See, I wonder, so that's one thing I always think about when it comes to like population data being skewed Northern Hemisphere, is that I think about all of those countries in the Southern Hemisphere, but then the two most populous countries in the world, China and India, are Northern Hemisphere entirely. The two most populous countries in the world, China and India, are in the Northern Hemisphere.
Yeah.
But And I just had a thought specifically about this because you were talking about the time zones. China is all one time zone.
Oh, it is too.
So I wonder how much that affects this. Does that make a difference?
There was a few other maps associated with this, and I think China is entirely included within the day section of this.
Okay.
Yeah, just by the way the shadow falls and things like that.
Yeah. That's always time zones are another thing that I get very excited and frustrated about at the same time, and China being all on one.
I skip straight to the frustrated. That's why whenever I have meetings, I always set them in universal time, because at least that one is unambiguous.
Yes,
none of
that's
this
true.
daylight savings nonsense.
Yeah. I mean, when I moved to Australia and found out that there were sometimes 5 time zones here,
Yes.
like, wait, what do you mean sometimes? And that took me down a rabbit hole.
Yes, absolutely.
I mean, this is a nerdy sentence that I say way too often. What a cool graph, Leon.
Fist bump for cool graphs.
Fist bump for cool graphs. We're going to do a real one, but our mics are really far away from each other. No, I think that more people should be more excited about a cool graph when they see one.
Yeah.
And this one, it even looks like an elephant.
New segment, cool graph of the month.
Let's just add more segments that are entirely unsuited for radio content.
Yes, absolutely. Oh dear. I think it's time to move on to our final segment, which is the new one we introduced last month. Is it Dictionary of the Month? No, that's not right. I honestly can't remember.
Well, we call it Space Dictionary, but that didn't alliterate enough for me. So I would like it to be called Deep Sky Dictionary.
It's time for Deep Sky Dictionary.
Thanks, Leon. So, Deep Sky Dictionary, this month, I've chosen a word that's not just a space word. Again, it's a perfectly normal word.
Mm-hmm.
I've chosen the word eccentricity.
Oh, that's one of my favourites.
It's a good word. One of your favourite just words or in space terms?
In space terms.
Okay, so I did some Googling, and Google says that definition number 1 of eccentricity is unconventional and slightly strange.
Mm-hmm.
Definition number 2 is deviation of an orbit from circularity.
Mm-hmm.
And I'll come back to that in a second because I think that Leon's going to get excited and tell us a bit more about it. But so eccentricity, the word, comes from the Greek ekentros. So ek means out of and kentron means centre. So off centre.
Yep.
So eccentricity, it was first found in English in 1551 as the second definition. So it was first found in English as deviation of an orbit from circularity.
Oh, wow.
So it originally meant eccentricity in the spaceway.
Wow.
Yeah.
Oh, there you go.
Yeah.
That's cool.
Yeah.
Because a lot of space terminology comes after the everyday terminology, but this is the other way around.
This is the other way around. It means primarily, it used to mean deviation of an orbit from circularity, which we then took to mean that's a little bit weird.
There you go. I've learned something there.
There you go.
Eccentricity is it's a strange one. It's a very useful number in orbits because you're right. A perfectly circular orbit, which is what you might think of as every spacecraft having a circular orbit, is perfectly circular, and so it's got no eccentricity.
No, it's 0.
And you can associate. There is a mathematical number that is the eccentricity. It's a number between 0 and infinity.
But it's not got any units or anything though, which confuses people sometimes as well.
That's right. Yeah, it's what we call dimensionless.
Yeah.
Sorry, this is my maths nerd coming out now. But basically, in a nutshell, imagine instead of a perfectly circular orbit, imagine an orbit that's kind of stretched out like an oval or an ellipse, perhaps, as is the technical term, and
or a squished circle.
A squished circle.
If you would like to be even less technical.
Yeah, and you can kind of see that the more you squash that ellipse into this really long, thin thing, the more it's deviating from a circle, and so you might describe it as more eccentric. And then mathematically, you just take the logical thing, where you take the thinner side of it and the longer side of it, and then you just kind of compare the two, and you do some square roots and some whatever, and you get a number, and then that number is 0 for a circle because it's got 0 eccentricity, and then as it gets closer and closer to 1, it means your oval is getting squished and thinner and thinner and thinner and thinner.
Until I guess you've got like a straight line and something going just backwards and forwards, and that would be...
Yeah, and that's when your eccentricity actually tips over 1.
Yes.
So for example, imagine you've got the the Apollo astronauts who went to the moon, when they first launched from Earth, and they launched into low Earth orbit, a few hundred kilometres up, in a almost circular orbit around the Earth. So their orbit... eccentricity basically zero. But then what they did was they fired up the engine again once they were ready to go to the moon, and then they stretched out their orbit so that the closest part of their orbit to the Earth was still near the Earth, but then the oval of their orbit stretched all the way out to the moon, so 400,000 kilometres long. So it was a really long oval, and so that they now had a very, very eccentric orbit around the Earth. But that on the far side of that orbit, it actually got close to the moon. And then when they got to the moon, they kind of went in orbit around the moon. Yeah. But imagine the moon wasn't there. That was still a very eccentric orbit around the Earth.
Yeah.
And if you keep firing that engine, your eccentricity goes up and it gets to 1, and then actually your orbit, the ellipse breaks and your orbit escapes and you go away from Earth. And so we talk about parabolic and hyperbolic orbits, which have eccentricities greater than 1.
Well, I think I've just found 2 more words that I need to add to future editions of Deep Sky Dictionary.
And here's one of the coolest things. All of the mass of this goes to, imagine a traffic cone.
Mm-hmm. I can do that.
Yes, and this is actually how they're defined in mass. Take a traffic cone and slice it exactly perfectly horizontally, like pull out your one standard Beth samurai sword, slice it in half perfectly horizontally.
Yep, absolutely. So I've cut the top off the traffic cone.
And you'll get a perfect circle with eccentricity 0, assuming the traffic cone is,
it has not been run over by something.
Yeah, exactly. Yep. That has eccentricity 0. Now,
no matter where I slice it.
That's right. No matter where you slice, as long as your cut is perfectly horizontal.
Yeah.
Now, angle your blade, maybe just down a little bit, so that you're not cutting steeper than the side of the witch's hat, but you're cutting in between horizontal and the side, cutting at a bit of an angle. Yeah. You'll get yourself a perfect ellipse with an eccentricity between 0 and 1. Oh. Now I want you to cut into the witch's hat at exactly the same angle as the slope of the witch's hat.
Oh, so wait. Yeah? Yeah, my mental traffic cone has been sliced at the same angle.
And and that's now what we call eccentricity of 1, and that's a parabola, which you studied in high school, the y equals x squared.
Okay, yep.
And now slice straight down.
Straight down.
That's a hyperbola, and that has eccentricity greater than 1. And they're all related to each other by the angle of this sword slicing into this cone, and they describe orbits of spacecraft around planets. So this maths that the ancient Greeks figured out has applications in spaceflight.
That's simultaneously awesome and also exactly why I got to the Wikipedia article for this definition, read the first half and then saw numbers and stopped reading.
And a certain type of person like me keeps reading.
But yeah, there you go. Eccentricity. It means now unconventional and slightly strange in common parlance, but it used to mean and only mean the deviation of an orbit from circularity.
And I think you've chosen a good one there. Great choice.
Thank you very much.
Well, that's it for this episode of Please Look Up. It's been a time and a half like it always is. Thank you so much, Beth.
Thank you, Leon.
And thank you for listening. We'll see you next month. If you want to hear more interesting space news, check out the website particle.scitech.org.au for more information. Shit, I should know that.
Don't worry, I don't know it either, Leon. This is when Leon goes, you should know that, Beth.
I should know that. Let's try that again.